We have a question here from Emily. Yeah, so Emily, it's the power distribution panel. So it's what your battery plugs into, pretty much, and that's how you distribute your power across your entire electrical system. Yeah. All right, go ahead and go continue, Alex.
All right, and then you got to take into account the location of specific electronic components. So, like, the router should be at the highest position, just to make sure you don't get any interference. Cameras, we use Javois normally.
Yeah, and cameras more on that. Try and communicate with your programming team or whoever where you want your camera placement to be, or at least generally. That way they can keep their stuff consistent as well. And so you should have a general idea of where those things are going to be going.
Right. Now, motors, you're going to want to take into account where the controllers are going to go, or if they even have controllers, and the number of motors which we ran into this problem this year. We'll talk about that more next slide.
And as far as pneumatics go, air tanks take up a lot of space. And so finding a good location for those, or at least ensuring that you're going to have space for those, is going to be really important. And you also can run out of PCM slots if you're too reliant on pneumatics, let's say. All right, and then we can just go ahead and move on to the next slide. Yeah, perfect.
All right, so what we did this year was we made a power budget because we were thinking about all of these cool designs that we had, and then we realized, wait, do we even have enough PDP slots for this? So if you can see the difference between these two graphs, one of them is with pneumatics, and then the other is without pneumatics.
Right, and so if you label everything and you have all your VRM slots labeled, you can keep track of those things as you add them on, or at least things you want to add. And so analyzing that along with the two different spreadsheets, like we said, can help you decide which route you want to go down. We went down the pneumatic route because we didn't have enough PDP slots for what we wanted to accomplish. And then also we made sure on that sheet to keep track of our PCM slots that we did have available. So at the bottom, there's that yellow and green graph that you can see. And then along with that, the VRM has a bit of a tricky rule set where it mentions that you can only have it on the single 20 amp Wago connector on your PDP. You can actually have two of them as long as you splice the wires onto the main lead. And so that's how you're able to get around certain problems with your VRM if you don't have enough slots on there.
All right, so reliability is a really big thing that you need to keep in mind when you're designing all of these mechanisms and how these wires are going to route through them. And something that we found really useful is sheathing. It protects the wires a lot. And we also found that cable chain, especially on elevators or moving components, will help the wires from not, crunching themselves together and causing a lot of problems.
And so the lesson that we learned from 2018 was that you should never underestimate a simple design that never breaks down. We try and implement this philosophy into all of our robots. You don't have to have your electronics board be neat, but you have to be able to maintain it, and you have to be able to have it not break. So it has to be consistent. And on that note,
Manageability. So something that's really important to our team is color coding for sure, because we often do find a lot of problems with our electrical layout, and it's super nice to have wires labeled so we can just trace them back and we know exactly where the issue is.
and so labeling wires also doesn't just have to be color. You can also label signal wires with masking tape and say, this is for our magazine sensor, or whatever sensor you're going to be using for that. And another thing to take into account is do not make large bundles of wire. You want to route similar groups of wires if they're going to a similar location together. Um, that way you can kind of trace them along a lot easier. But try to avoid, if you have an extra long length of cable, looping it together and then just zip tying it. That can cause quite a bit of confusion whenever you're going back through and trying to trace everything around. But color coding should help even with that. But that's not a end all solution.
And so the functional design of the robot, what we mean by this is really how are you going to make these electrical components withstand all these crazy mechanisms that you make, like vibrations and wire movement.
Yeah. So, for example, on a shooter, the big things you have to watch out for is that flywheel's spinning pretty fast. You're gonna have a lot of vibrations. Might get knocked loose, pulled apart. So, using things that hold cables together, at least connections together, is gonna be really helpful. Uh, Obviously, keep your wires away from the wheel or a chain if you're running that along your flywheel, because you don't want to have a fillet of wires going everywhere. Um, and with multi-directional arms, things that we had in our 2018 robot, you want to be careful about how your wires are going to be moving if they're going to be put in harm's way. And so cable chain, if you're running a repetitive up and down motion, is really, really handy for that. And cable chain can also be used on elevators as well. We even try to use cable chain in our 2017 robot with a turret. However, you got to keep in mind that that was a very tight space, and the cable chain was not designed to be a bi-directional component of that. And we actually made a manual version of a bi-directional one, and it didn't turn out so well. So you ended up having problems like wire shearing within the cable chain, and also things getting unplugged, and that resulted in a lot of hassle. And then another thing to look out for that we ran into this year was storage of game elements and game pieces. So we had to hold 5 balls this year in our robot, and so sensor placement with those is extremely important. So analog sensors near motors can have interference because of electromagnetics, and then also having a NavX, which is also a sensor, in a vicinity of a motor can cause a lot of issues. But the main thing you have to look out for with that is that those game pieces have to be somewhere. Your electronics aren't incorporeal, so be ready whenever suddenly all your space is being taken up. And so we have some inspirational quotes that hopefully some of you can relate to. So this is one of my quotes. I swear if I see another one of you grabbing a battery by its cables, I will smite you. And this is because every time I see this, it makes me cringe on the inside. And that's because as you wiggle those by the cables, because your hands hurt or whatever, they will break. And then it takes a while to remake them as well as you did before. And so constantly having to remake those batteries, and it can also wear down connections over time, causing more resistance, and your robot performance goes down. And also batteries tend to be pretty expensive, especially every season whenever you run them dry after every single match. And next up, we're going to be talking about constraints. So these are going to include rule constraints, design constraints, and team-imposed constraints. So rules are the easiest to find because they are written down for you in the game manual. So this is going to be things like your power switch location has to be a certain way, or you can only have one connection of this type on a motor controller or whatever. And then there's design-based constrictions. So just because you're allowed to do it within the rules, is there a good reason to do it, right? So just because you can put your router sandwiched between 2 metal plates, is there really a good reason to do that? And then, of course, there's team-imposed restrictions. These are ones that are brought up as designs usually change. So they usually include something like, oh, all of a sudden our turret is in the middle of your electronics layout. And so you got to find ways around those. Those things just happen. But that's also a part of communicating with your mechanical or design members. And we can go on to the next one. So like I was talking about, there are certain rules. There's Rule 64, Rule 65A, Rule 43. And so those components need to be very particular. So, for example, the diagnostic lights on the wireless bridge radio actually need to be visible to the arena personnel. And then the RSL, of course, needs to be visible within 3 feet if standing in front of the robot. And then, of course, the power switch needs to be easily accessible from the exterior of the robot. And rules do change from year to year. So, what once might have been really restrictive can now suddenly have a weird rule change that has an advantage to abusing it. Um, and however, these are non-negotiable requirements that you must have for certain components. So there's just no way around them. And so then design constraints are things that you want to do that make sense. So for example, the wireless radio, like we said before, you want it to be placed high up on your robot. And that's because if you put it lower, you might have interference signal. In battery cables, you want the smallest run of battery cables as you can, because as your distance increases, you actually have power loss, which is not very good. Rubber reel, we have found that you definitely want it in an accessible location. You're going to be unplugging and replugging a lot on the practice field, and that can get rather annoying if your rubber reel is sandwiched in between two sheet metal plates. And then also protecting components is a huge part of this, actually. So your router, your rubber reel, and your camera. We actually had a 2019 robot. Our router got punctured during a match, so there was just a hole in it, and it turned off. And then also, secure your battery, please. We have found that having a vertical battery mount, at least for us, results in pretty much zero batteries drop. And as you can see by this GIF that I found, this is our 2018 robot Scimitar getting its battery just jettisoned out of its holder. You will get e-stop for that. It's not a good time, and please avoid that. It makes you look silly, and nobody wants to look silly. All right, we can go on to the next one about team imposed. So this situation sounds familiar. So you just designed where all your components are going to be placed, and then the mechanical team decides to place the shooter right in the middle of your layout. And there's absolutely no problem with that. So first of all, calm down. It's going to be okay. You've probably been through worse. And you got to be flexible, you know. You have to be willing to move everything around. And you got to communicate with your mechanical team members to see if you can get any leeway on space. And on that note, you have to defend your space if you absolutely need it. If you simply can't put, a battery in a space that won't fit it, or is just going to be extremely inconvenient, unless it's your only option, try to make sure that they understand what they're going to be causing, right? It's a back and forth between those two. And it helps if you CAD up your electronics. This is why we do it. Is so that way you can integrate with other sub-teams. And so what we do for CAD, just the basics, is we have the main components on there. We don't have any wires that are CAD'd. That takes quite a bit of time. And SolidWorks, the program that we use, doesn't make it very easy, I would say. And if you can, leverage changes positively. So if there's like a new beam or something, you can maybe put a sidewall up there and have new components and new areas to open up. And this picture of our 2019 robot highlights the very restrictive space that we had. We had a area limit, and then we also had a height limit. So we ended up having to use shelves. You can do them right. We definitely didn't. Could have been a lot better, and there's always room for improvement. So everything was kind of crammed in there and a bit hard to reach. And so FRC seasons are just full of everyone screaming for one reason or another. So that's a very inspirational quote.
Okay, next is our ordering process. So why do we do this? Well, because our mentors make us do it, but also because it helps us give us an idea of what we need and what we are limited to. So first we start with our inventory, taking everything that we have and counting it. Even though it's time consuming, it's worth it. Then we create an order proposal going through a bunch of websites and trying to find the best deal. We present it to our mentors, and then we actually place the order with our coaches. So inventory, count how many of each component you have, and even though it takes a while, you don't want to be you don't want to find out in the middle of a match, oh no, I don't have enough power poles or ferrules, and not be able to fix any of your wires, which is not good. You also want to count wire lengths and sheeting, because those are two big things that if you don't have enough wire to make something that needs to go from one side of the robot to the other, you won't be able to power everything that is needed. Also shielding, because you don't want to like get your robot wires torn apart when things are moving very fast. Also electrical components like the PDB, TCM, and VRM. Those are some key components that a lot of people use, so they're on first choice. And you also want to go through first choice before you like go and check other websites, because a lot of times they have some pretty neat things. Also use the vendor vouchers, because they do give you discounts, which is nice to save money. Also, you also want to find new components, so you don't always have to use the same thing every single year. Try to venture out and see if there's a better option to what you're currently using, because it might not always, what you're using currently might not be the best option. So also talk with other teams, see what they're doing and how they're doing their electronics, because you can always get new ideas from them and improve your own electronics board along with it. So this is our inventory spreadsheet. It's pretty much a long spreadsheet of everything that we have, and we go through and we count everything, and we type in the numbers, and we put in some equations to kind of give us a basic idea of how much things are and how much we need of specific things, and then we add on top of that like coupons, or if we have certain like bundles that keep things kind of lower on the budget end. So after inventory and counting everything up, you go through and you get all your websites and your vendors. And you want to make sure you use spreadsheets, because they're really nice with equations, so you don't have to go in and actually do the math on a calculator for every single component you have. It also makes it really easy to like share with mentors. And while you're going through each of your components that you need, make sure you have a reason for why you need it. Because you could be, oh, I need to get an extra PCM, and then you have to know why you need an extra, VRM. You want to know why. Because you might just be adding a bunch of things that aren't necessarily needed. And you also want to do shipping cost does factor into what you're ordering. So try to order things in bulk, if that makes sense. You want to have your order complete for each vendor before you don't want to go off. Like one day you need to get one thing from a certain vendor, and then the next you need to order something else from the same vendor, because those shipping costs will become a little bit pricey.
Yeah, in general, you want to keep objects on your order to close to one website, or grouped it to multiple websites, so that way you don't have to pay for shipping 3 times in a row for no reason, because Amazon offers it as well, and then you can get free Prime shipping.
Ooh. Also consolidate your vendors, because it's easier just to get something from one place, but make sure it's the best decision for your team. And also there are some discounts on quantity discounts, which is if you're getting like 40 or more, or just bulk is normally cheaper. So this is our ordering spreadsheet. You can see how it's different from our inventory spreadsheet, because here we split up everything that we want to order into each of its vendors. It's like we have Amazon, and then we have quick order and other things that go on under it. So we move the Robo-Rio again, or the compressor again, also the router again.
Sit.
Okay, you're good, Alex.
All right. So, team practices. There are a lot of standards that we have when crimping wires, you know, making wires, catting. So we're gonna go over crimping, board design, mounting, and securing components, sensors, CAD, and pneumatics. So crimping is really important when you want a wire to survive a season, for sure. Um, oh, and before I start anything, all of these tools will be listed at the end of the presentation that we use.
Where's my shirt?
Okay, so you want to explain? So an idea that our team likes to implement is whenever you get get down to business and just start crimping wires, you got to make sure you have a formula in a way. For example, whenever we use Anderson power pole connectors, we have a rule that's like a mnemonic device kind of, which is red on right, tongue is up, which is how the crimp should be oriented whenever you are actually crimping it. So that way, whenever your cables are standardized, you can actually swap them in and out if you need to. So that way you can make spare cables, which makes it incredibly easy. And then the other thing to keep in mind is that you should be using the proper crimpers for the crimps. Pliers, vices, or anything else isn't going to get you a good enough connection on those sorts of things that will actually last through an FRC match. They will be immediately torn out. All right.
So the past few years, we've been using 1/8" sheet metal for our electronics boards. You can also use carbon fiber, but be careful, it does conduct electricity. And we do like to use Lexan or aluminum for covers because, especially with upside down electronics boards, you will want a cover.
Yeah, we don't really want anything getting jammed up in there or anything getting snagged. That would be a bad situation because all your wires are facing downward. Go and move on to the next slide.
So when zip tying cables down, you don't really want to put a lot of strain on them because they will start to shear on corners and parts of the robot that are pretty sharp. We use cable tie mounts a lot when there's no other mounting solution, which is this little picture on the left. It's just got a little adhesive on it and you stick it on, it's super useful. And we also use double-sided sticky tape when mounting components to help with vibration a little bit, and especially on upside down electronics boards, it gives it a little extra security when you're mounting it. Now, when you're mounting batteries, vertical mounts result in less dropped batteries, which we've already talked about. And you either want to use an elastic band or buckle to secure it is what we've found what works best. And yeah, we've learned this the hard way too many times. Alright, so for sensors, you're gonna want to plan on where these are gonna go ahead of time. You're gonna want to communicate this with the programmers, and you're gonna have to take into account how you're gonna run these wires from wherever they need to go to the sensor.
So for example, if you're using something like a beam brake and it's sort of two separate components, you're going to need, at least for our beam brakes, you need one power that actually emits the signal and the other one that receives it. And so you're going to have a Y split along there somewhere, or a separate power to the other one. And you also have to keep in mind what type of signal wire you're actually going to be using. So is it PWM, DIO, analog, or is it like a relay signal? And then how long will the wires need to be? So if the sensor is on a moving component, such as an elevator, be sure to give a lot of slack to the wire so it can actually move. And also label your sensor cables. We learned this the hard way as well. Usually with colored electrical tapes, that way you can trace back which ones and look at a sheet as to where they're going. And then there's also rigid mounting solutions you have to keep in mind, such as limit switches. Try and add hard stops there, especially. Camera mounts have to be rigid and consistent, otherwise equations with vision targeting get all messed up. And then also your light ring can also screw with that if it's not mounted securely.
Alright, So we use SolidWorks to design all of our components, and this is super useful to the mechanical team as well, so we can easily communicate where the mechanisms go, where we're going to put our electronics. And we use this linear circular sketch pattern for those of you who know how to use SolidWorks, to create this lattice effect to save a little bit of weight.
Yeah, and the thing that we do is we just don't have like a full render of any of the parts. We actually just use boxes that represent them, so that way you can just get the general idea of where things are going to be going. That way you don't have to sit on your laptop and wonder why nothing is rotating. Go on to the next slide. And then as far as pneumatics go, how we mount pneumatics, the thing you have to really watch out for is avoiding sharp turns with your pneumatic tubing. Pneumatic tubing tends to not perform too well whenever it's at a sharp angle. It increases pressure, and then you're also all of a sudden going to have a burst tube somewhere. So make sure you watch out for those failure points. As far as what we use, we actually don't just use 1/4-inch tubing. We also use 1/8-inch tubing for things like pancake pistons with really small stroke, so it doesn't need much power. And then quality fittings, you want to make sure you're using those and check the quality of them. We like to use McMaster and Automation Direct. That's where we get our fittings from. And then also quality tubing. The tubing that we use for McMaster is actually weld spatter resistant, and it's this crazy stuff. It's abrasion resistant, and it's super durable, but it also does not like to bend as much. So a lot more push-to-connect unions are needed for those sorts of tubes. And that's Howdy by Jack. All right, next. All right, so now we get into the meat of the section, which is our upside-down robots, upside-down electronics board, so our robots. So our 2018 robot lended itself pretty well to an upside-down design. That's because it was very simplistic and didn't have many complicated mechanisms on there. Since our team was so small, there was easy communication between electrical and mechanical sub-teams, and it was really quick maintenance because we had pretty much the entirety of the bottom able to be removed, so that way you could flip up the robot and just immediately fix anything that may have gone wrong. And then that also allowed for components and wires to be really safely secured, so we could zip tie them down every single inch. So everything stayed put and rarely ever broke. And then we can go on to the next slide. And as opposed to our 2020 robot, where there was really rapid changes, led to lots of redesigns, there was limited space due to the complexity of the robot. So we ended up having a lot of manageability issues, a lot of robot design constraints, improvements. There were a few things where we could have grouped wires a bit better together. We could have added standoffs on top of the superstructure to allow more space for motor controllers, since Spark Maxes tend to stick close to their motors. And then also we need to move our camera mount recently, so we have to design a adjustable camera mount that's actuated by either a servo or a piston. The next slide. And so our 2020 CAD robot design, this is interesting. So we had to do a staggered electronics board just so that way we could fit the battery, because the magazine that we had actually was taking up most of the space. And so that's kind of the main feature of this one. Otherwise, we follow the same rules that we always do with the PDP being centered. Go on the next slide. And so some generic upside down tips. Use a removable cover on the bottom of your robot to protect vital components. Preferably, it should also be clear. So if you have any issues, you can actually see signal lights through it without having to take it off if you have it riveted on. Assemble components before mounting board onto the robot. This helps quickly get the chassis up and running if you're doing something like that. Certain components need to be visible, such as the robo-reel or the RSL or the power switch. You need to check the rulebook for that. And certain components may be too big to fit underneath. For example, air tanks. If your chassis tubes aren't tall enough, you'll actually be scraping your pneumatic air cylinders across the floor pretty much. And then also add access points for wires to reach the mechanisms. So add slots that can reach up to your arm mechanism or your elevator. And those are the main things to really look out for. Otherwise, it's actually pretty similar to a regular electronics board. It's upside down. You got to look out for a few things. All right, we can just go ahead and skip that slide.
Troubleshooting. Okay, so when you're getting a problem from someone, you want to make sure that you narrow which components could be the issue and that it's actually an electrical problem. So when you're doing this, you want to make sure you have a voltmeter to check if wires are um, transferring electricity, and if they are and making sure they're not sheared or if they're disconnected on either side. So you can make sure everything has power and everything's getting its data and signals. And you also want to use the process of elimination. So you want to take this big problem, make sure it's an actual electrical issue, and say, okay, I have these 5 components. Let me make sure they all have power, they all are sending signal, and then once you find like 1 or 2 that aren't, you focus on those 2 components, and you're able to find the problem fairly easily. Which is also nice when you have like an organization with your wires. It's easier to find problems and trying to troubleshoot between matches, because that is very useful when you'll need like 15 minutes to find the problem and solve it before your next match. And always wear your safety glasses, they're needed.
All right, and so for this slide, we were actually going to ask you guys if you had any interesting lessons learned, but first we're going to go over ones that we have learned as far as our FRC career, I guess you could put it, has gone. The first one is communication is key. Things fall apart as soon as you don't tell each other what the heck you're doing. Test every connection after a match. Wires aren't perfect, neither are you. You got to make sure that you're keeping those in check. Otherwise, all of a sudden, your radio goes down for no reason. So never assume a wire or a crimp will last forever. They do wear down. Expect a lot of unplugging and replugging from the Robo Rio, like I said before. And also, especially with just this in general, make spare cables of things, especially the ones that are really hard to make. So encoder cables can be really finicky, especially if you're splicing on connections to those. Those cables can get really complicated.
So one that I would add to that is, after you've got your superstructure or your mechanism on, double check the ease with which you can get your battery in and out. We've had a couple times where that wasn't considered, and it was a bit of a maze or Tetris to pull and replace batteries between matches.
Definitely. All right, so here we actually have the crimpers that we use. I'm not sure if we should have a QR code on there. So if you want to scan that with your phone, that's actually all of our crimps and crimpers listed in a nice, easy format to understand. You can calculate the prices out. It'll tell you which each one will cost. And so those components are pretty important. The precision microfit crimper especially can actually be used for multiple different types of connectors, such as Molex microfits, or even header connectors. So those are more of a multi-purpose tool. And then pneumatics, what's really important is getting an even cut whenever you're cutting tubing. And so pneumatic tubing cutters are actually really handy if you want to prevent leakage of air, because you get a lot of an even cut because it lets you align it really nicely.
Yeah, I'm glad you put the pneumatic tubing cutters on there. Just having like a plier style cutter makes it real easy to get a diagonal cut, and you'll be chasing that down on the entire season.
I think we're ready to move on to questions if anyone has anything that we want to discuss.
Thank you very much. Great.
Thank you.
Lots of great information. I think folks are still scratching notes and those types of things. We'll make sure slides are available for folks afterwards as well. I really appreciate you guys taking the time to put this together. Great presentation, good information. I appreciate the help with the multi-team meetings. I think this will help out everybody.
Yeah, I think that was really well done, guys. I would the only question I would have for you is if you could only tell an electronics team one thing to watch, what would it be?
For at least for us, most of the problems arise whenever you don't communicate. So the thing you got to make sure about is that while you're designing, just be in touch with the mechanical people who may be designing something new. Make sure they know where you're going, or at least you know where they're going, so you know to avoid it. Um, because what ends up happening is you have all this stuff that's actually been fabricated and put together, and then you end up not being able to use it because you have to redesign it anyway. And so what can actually help with that is if you have something like a prototype bot. So just like a chassis with like some wood beams on it, right? So you can get a general idea of where things are going to go, of course. I wish I had something that was more particular that I can say this is the one problem. But it differs from team to team, from what I've seen, and other teams have different issues. So you got to just figure out how to identify that, and just issues in general, really, and figure out how to work around those.
Well, actually, Cooper, I thought that was pretty well worded. I think that is probably the biggest thing on any robotics team is the communication. If you don't have that, you're in trouble. so well said.
Thanks, everybody. That was our presentation for today. Are there any ideas of things that you would like to see as part of these multi-team meetings before we cut out?
If it's not too much trouble, oh, sorry, hold on.
Yeah, go ahead. Oh.
Yeah, it'd be cool actually, because I know this was mainly like an electronics meeting, but we could even look into trying to get like the vision people from different teams to get together and I guess convene about different algorithms or approaches they use to solve the issues.
Okay. Yep, we'll put that on the list.
I have a question about the electronics.
Uh-huh.
What do you prefer to use to mount like various electronics components? Like, do you prefer bolts, Velcro, whatever?
Velcro, usually not. It really depends on the component that you're using. For example, with a compressor, you have to kind of use bolts, otherwise it sounds like a diesel engine. As far as motor controllers go, most of them are either designed to use zip ties or have the option of either using zip ties or bolts. We personally like to use zip ties because they just take up less weight instead of putting a bunch of steel rods through them. It just kind of adds up over time. And also with mounting certain components like air tanks, there are certain things you can do to mount those, like 3D printing round components, or we even have air tank clips that we actually get from McMaster, but those aren't really for everyone in every situation. But they're pretty low profile and can help out a bit with that.
Great question, thanks. And yeah, it does kind of depend on the part, so some good options, Cooper. Thank you. Any other question, comments, or topics you'd like to see covered in one of these multi-team meetings?
This is Dakota from 4418. Did you ever have any RF transmitting issues when using a carbon fiber electronics board?
I believe, from my experience, I think I've only used one carbon fiber electronics board technically. I don't think we had any transmission issues, but that really depends on the placement of your radio. As long as your radio really isn't blocked in by carbon fiber, it should be okay.
I'll step in here for you, Cooper.
Yeah,
we used a lot of carbon fiber electronics boards before Cooper's time. Yes, you can have transmission issues with a carbon fiber electronics board. Magnetar didn't really have them, but our 2014 robot using the old D-Link routers most certainly had some carbon fiber interference issues that caused enough problems that we had to reposition the router. Um, that being said, that's the old D-Link routers. The new ones are a little bit more powerful, so that might not be an issue. And when the robot that we strapped it on, we were still really new to carbon fibers, so we did our boards a lot thicker than we do them today. And so that would have also contributed to the interference pattern we had. It's possible, but it's unlikely.
Great, thanks.
Jack, we could do also, speaking of carbon fiber, we've done it for mentors, but we could also have a kind of a carbon fiber discussion. We have made, I think every season we make something out of carbon fiber. So I know the team has gone through years of different things and what works better and what doesn't. So we could do that too.
Great. Appreciate the offer. And yeah, we'll try and get you scheduled in for that. I think that's definitely a topic of interest.
Yeah, it's a lot of fun too.
All right. If there's nothing else, thanks everybody for joining. Really appreciate the participation from so many different teams. And keep your eye out for more invites. I'll probably continue to send them through the mentor group. For those of you that shared emails, I'll add you to our distribution as well, so you can come back to these. That's all we got. Thanks, everybody.
Thank you.
Yeah, thank you for letting us present, by the way. That was awesome. I hope people learned something. And if you have any questions, I think I included my email. So if there's anything you want to know, just go ahead and shoot me an email, and I'll see if I can get back to you. School's been a bit rough, though.
Yep, I understand.